Now it's time to start working on actually taking numbers and putting them into what we're going to call their prime factorization, or breaking them up into primes. And we're going to start with the number 30, and I'm going to talk my way through this one, and then I'll give you some problems to work on, and then after you get done working on it, we'll work on them together, make sure that everything is right. So let's start with the number 30. The process of finding a prime factorization is, I prefer to start with the number 2 and ask, does 2 go into 30? And 2 in fact goes into 30. 2 is 2 times 15. And so I write that up, 2 times 15. And then I ask, does 2 go into 15? No, it doesn't. So I move on to the next prime. And the next prime after 2 is 3. Does 3 go into 15? Well, it does. It's 3 times 5. Now it's my preference to start with 2 and continue to take out factors of 2 until there aren't any left. Then start with 3, the next prime, and take out 3's until there aren't any left, and then 5's, then 7's, then 11's, and on down the road. That's just how I do it, but you're going to see that you can do it in multiple ways. In fact, in a couple of problems, I'm going to give you another way of thinking about it. So, we started with 2 times 15, we broke up 15 as 3 times 5, and now because 3 and 5 and 2 are all primes, that's the prime factorization of the number 30. Now, we talk about the 2 and 3 and 5 being the leaves of the tree, and that this is a factor tree, and there are branches and there are leaves, and there's a whole bunch of vocabulary there that really will help somewhere down the road, but not right now. As long as we can get down to 30 is 2 times 15, and 15 is 3 times 5, and that 30 is 2 times 3 times 5, those end numbers, all those numbers that are primes, that's where you want to be right now. Okay, now there is something kind of big theoretically that's going on here. And that is that there is something called the prime factorization theorem. It's also called the fundamental theorem of arithmetic, that says that for every number greater than 1, that each of those numbers can be written uniquely as a product of prime numbers, which means that the only way you can break up 30 is 2 times 3 times 5. It also means that 2 times 3 times 5 can only multiply up to 30, and if you think about that, 2 times 3 is 6, 6 times 5 is 30. If I multiplied the 2 and the 5 together and waited for a moment on the 3, 2 times 5 is 10 times 3 is 30. No matter what structure I do, no matter how I multiply those three numbers together, I always get the number 30. That's kind of a nice thing to know. Now, factoring things into primes is going to help us in these types of problems. The first one is just reducing a fraction. We're going to do that in just a little while. The next two have to do with polynomials, and we're going to break those into primes also so that we can do certain things with them. And so just be aware of the fact that the idea of breaking things into primes is going to actually be a tool we're going to use a number of times. So let's move on to actually practicing breaking numbers down into products of primes. We're going to start with the number 12. And again, hit pause for a moment and ask yourself, how do I break this into primes? And then when you're done working on it, come back and I'll talk through it also. Well, we start with the number 12 and ask, does 2 go into 12? And it does. It's 2 times 6. And then we ask, does 2 go into 6? And it does again. It's 2 times 3. And so 2 and 2 and 3 are all primes. And so 12 is 2 times 2 times 3. That's how it breaks into a product of primes. Let's look at this next number, 75. Again, give it a try. 75, 2 doesn't go into 75, but 3 goes into 75. We can think of it in two different ways. One is that 7 plus 5 is 12, and since 3 goes into 12, 3 goes into 75. Or we can think of it as 75 cents is 3/4, so it's 3 times 25. 25 then breaks up as 5 times 5. The 3's and the 5's are all primes, and so 75 has to equal 3 times 5 times 5. Next, the number 36. Well, 2 goes into 36 18 times, and 2 goes into 18 9 times. And 9 breaks up as 3 times 3. And so, when we look at that, 36 equals 2 times 2 times 3 times 3. So that's 36. Now, here's a place where we should do this a second time. 36, most of us when we think of 36, it's pretty quick to think of 6 times 6. And so here's 36 is 6 times 6. And then 6, the first 6, breaks up as 2 times 3. The second 6 breaks up as 2 times 3. But in each case, when you look at the leaves of the tree, if you will, there's 2 2s and 2 3s. And so, regardless of which direction we break it up, as long as we make sure that we divide things out correctly, we're always going to get the same answer. That's kind of a nice thing to know. When we look at 48, 48 is 2 times 24. That one's actually not too bad. You can see 2 going into 48, 2 goes into 4 twice, and it goes into 8 4 times. And 2 goes into 24 12 times. We're pretty familiar with that one. And 2 goes into 12 6 times. And 2 goes into 6 3 times. And so 48 is 2 times 2 times 2 times 2 times 3. Sometimes we write it as 2 to the 4th power times 3. And we'll work on powers in just a little bit. 108. How do you break up 108? Well, 108, 2 goes into 108 54 times. And 2 goes into 54 27 times. And 2 doesn't go into 27, so we asked, does 3 go into 27? It does. 3 goes into 27 9 times. And 9 breaks up as 3 times 3. And so 108 is 2 times 2 times 3 times 3 times 3. See, these are getting a little bigger. Let's do something even bigger than that. Let's look at 270. Well, let's see. 270. 2 goes into 270 135 times. And 135 can't be divided by 2, but let's see. Can 3 go into it? 1 plus 3 is 4. 4 plus 5 is 9. So 3 goes into 135. And if I just go off to the side paper and say 3 divides into 135, I find it goes in 45 times. So I've got 2 times 135, and 135 is 3 times 45. Oh, 45 is 3 times 15. That one's not too bad. And 15 is 3 times 5. And so 270 is 2 times 3 times 3 times 3 times 5. Now again, sometimes it's way easier to break this up in a different way. For example, 270, well, 27 is 3 times 9, so maybe I break that up as 3 times 90. And 90 is 3 times 30, and 30 is 3 times 10, and 10 is 2 times 5. And so again, I get 1, 2, 3 copies of 3, and a 5. Well, that's the process of prime factorization. And you're going to see as we go down the road, that's going to show up a number of times throughout our course.